The last method we're going to talk about in this section is the nearest neighbor method. Okay, so this is a way to approximate solutions to that traveling salesperson problem. So first you model it with a graph, a complete weighted graph. Identify the vertex you're going to use for your starting point. From that point, choose the edge with the smallest weight. Okay, go along that edge. Then from that edge, choose the next edge with the smallest weight, but you want to go to a vertex that you have not already visited. Okay, then go along this edge. You continue doing the same thing until you're done and you return to your starting point. So let's look at one. So here's an example where we have the nearest neighbor here. It says we are going to start at A. We have a completed graph. We want to look, it just chose to start at A. So let's look. 128, 147, 114, 180. So we're going to choose this 114, and our first stop is going to be down here at C. So we went from A to C, and that was 114. Now we're at C. And from C, I've got to figure out which way to go. Okay, so this way is 114, but I've already been to A. We don't want to do that. I can go here for 116, or I can take this one across for 115, this one for 169. That's my four choices. I don't want to go to A, so I'm going to go next from C to E, and that's going to be 115. Now I'm at E. I don't want to go back to A. I can go to B for 195. I haven't visited B. I don't want to go back to C. I can go to D for 194. So this one is the cheapest right here, the shortest. I'm going to go down here to D. Then from D, here's my choices. I don't want to go to A. I've already started at A. I don't want to go to C. I've already visited C. So these pink lines are all the things I've already done, okay? So from here, my next choice would have to be B. I'd have to go to B, and that's going to be 145. And then from B, I only have one thing left to do. I have to get back to A, and that is going to be 180. So you add all that up. Here's everything added for that circuit, and it is $748. So that's using the nearest neighbor method to come up with an approximate solution for the best optimal Hamilton circuit.